In this example, we've got x squared. We'll deal with x squared early on because it's a pretty simple function. And what we want to do is find the area here between the curve to the x-axis and the lines x is equal to 1, x is equal to 2. So that's what it looks like. Simple graph will tell us, oh, that's where our curve looks like. Our area is in there. So what we want to do is find the area by using the integration. So our limits of integration will be 1 to 2. And we're going to have x squared dx. So we're going to integrate that one again. Gives us x cubed on 3. Substitute 2 in, substitute 1 in, and then do our calculations to give us 7 on 3 or 2 and a third. So that's the area under that curve. In the next one, again we got x squared, but this time we're going minus 1 to 1. So this is what our curve is going to look like. We're going from minus 1 through to 1. So our area here is in these two parts. So we can throw it in the integration. So minus 1 to 1 of x squared dx. Again, integrate for x cubed on 3. Put in 1, put in minus 1, and we get 1/3 plus 1/3 and gives us the 2/3. So if we start to look here though, we might start to notice that there is a little bit of symmetry happening. So we can start to use a couple little tricks to try and do this. So if you hopefully you notice that the area on the y-axis was exactly the same. So that's because we get an even function. So if we can actually recognize that or see that we do have this same area on both sides, then we can start to use a little trick to go, well, let's just, instead of going from minus 1 to 1, let's go from 0 to 1 and double it. And that's quite fine to do because it's exactly the same. So you're just doubling whatever area you got in this part. Now you've got to be able to double it when it's only, you can only do that when it is the same area. So we can do the doubling effect here and use 0 to 1 of x squared and then put it in there and get 2 lots of 1/3. Now it's up to you. You could still go negative 1 to 1 and that would be fine. I like doing it this way because I get the 0 in there. I just find it easier when I'm able to substitute 0. A little bit less calculation in my integral, and it's still going to be the same, but it only works if the area is the same. So be really careful. Sometimes your areas may look the same, but it depends on your drawing. And so you've got to be really careful about what your limits of integration are and making sure you do have that even function.